in Algebra 2, when we start talking about inverse functions, right? One of the things we say is something like this. Something like this. Okay, so if this is f of x, we say that if f of x passes the horizontal line test, then its inverse will be a function. Okay, meaning horizontal line test, if I draw a series of horizontal lines, if each of these lines crosses the graph only once, then its inverse will be a function. In fact, if I draw the inverse of this, it will look like this. All right? So basically, it like flips over sideways. X and Y get switched. Now, maybe it'll be like a little bit thinner. Okay? Now, if I have f of x that looks like this, clearly that parabola doesn't pass the horizontal line test, right? Meaning its inverse, which will look like this, will not be a function, right? That sideways parabola is not a function because it doesn't pass the vertical line test. So what do? In order for us to be able to find an inverse function of this parabola, we have to restrict it so that we only take 1/2 of it. Okay? We call this restricting the domain. So we say, okay, let's just restrict the domain so that x is just greater than 0. We don't look at the other part of the graph. Now, the inverse of that will be this, and that is a function. Okay? So, we're going to take that idea, and now we're going to bring it into trig and sine and cosine. If you look at a graph for the sine function, clearly it does not pass the horizontal line test, right? So what does that mean? Are we just going to say, okay, that's it, so much for the inverse function for sine, let's give up? No, of course not. I'll get you in a minute. What we're going to do instead is we're going to take only a segment of this graph so that it does pass the horizontal line test. And so we could take this part, or that part, or this part, right? So we could do like only from here to here, or only from here to here, or only from here to here, so that it's gonna pass the horizontal line test. It's most desirable that it's as close to the origin as possible. So that means the best option is if I take only that segment of the sine of x graph and I throw away everything else. So when I only take this blue part, that part of sine of x can have an inverse function, right? So in the world of the inverse function then, anything to the left and right of that blue part does not exist. What does exist? Everything from negative pi over 2 to pi over 2. Okay, question. Yeah. Yes. Yeah. Okay. Negative pi over 2 to pi over 2. Okay. Yes. Sine of x. We're just talking about sine of x now. You can always like truncate and take a segment in order to find the inverse, but for now we're just specifying the domain for the sine. Okay, so if this is from 0 to pi over 2 on the right hand side, what other angles are here? There is pi over 6, pi over 4, pi over 3. Is that right? And then on this side, there is negative pi over 6, negative pi over 4, negative pi over 3. I can barely see it. Okay? So, in other words, this inverse sine is only going to exist for these angles. How many angles are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, what we just did then is for f of x, we restricted the domain so that it only goes from negative pi over 2 to pi over 2. Okay? Yeah. Yeah, it's basically, it's like the special angles, pi over 6, pi over 4, pi over 3, right? Okay. Now, what's the range of this region? It goes from negative 1 to 1. Okay? Okay. It goes from negative 1 to 1. All right, so now that we've done that, we can find the inverse sine function. Okay, so the inverse sine function is written like this, right? Remember f inverse, sine inverse, or arc sine of x. These are synonyms. You could interchange them. Okay, now, okay, take a look here. This is a graph of the inverse sine function on the bottom. What's the first thing that hits you? Focus on the x and y axis. What's the first thing that, They're switched, right? Look, whereas negative pi over 2 to pi over 2 was on the x-axis for sine, now it's on the y-axis. Whereas negative 1 to 1 was on the y-axis, now it's on the x-axis. Is that normal for f of x and inverse f? What's the first thing you do in algebra 2 when you have to find f inverse? You switch x and y. So, if this was the domain and range for f of x, the domain and range for f inverse, it's going to be the inverse, right? So the range will become the domain. Oh. Yes. And it's so exciting. I love this stuff. And the range will be negative pi over 2 to pi over 2. Okay? Okay. So, what exactly is it that we're talking about with this inverse business? Okay? What I'm talking about is this. One of the expressions that I can write with inverse sine is inverse sine of root 3 over 2 equals what? Okay? So, if I was walking down the street and there was a billboard, and on the billboard it said inverse sine of root 3 over 2, I will say to myself, oh my God, somebody is looking for the angle, the sine of which is root 3 over 2. So what is that angle that has sine root 3 over 2? Pi over 3? Does that make sense? 60 degrees or pi over 3? So pi over 3. Okay, so we're going backwards. Until now, I was like, hey, what's sine of pi over 3? And you're like, it's root 3 over 2. So now I'm like, what's the angle, the sine of which is root 3 over 2? And you're like, it's pi over 3. Okay? So now, if I write this in more general form, it'll be like this. Inverse sine of x is equal to y. Okay? Yeah. Yep. Everybody does in the beginning.
3 over 2 has nothing to do with this problem. It was just, like this specific problem, it was just like a clarification for the inverse.
Yeah. Okay, so now, here's what's important. It's usually written inverse sine of x equal to y. So this is your x value or your domain. Okay? So your domain values are what go in here. For inverse sine in green, what did we write for the domain? That it's negative 1 to 1. So at any given time, the number that goes in that parenthesis for inverse sine must be between negative 1 and 1. How much is root 3 over 2 these days? If you put it in your calculator, it's 0.8660. Okay? It's between negative 1 and 1. This number here, that's the range. And it must be between negative pi over 2 to pi over 2. So, here is the deal. If I ask you what is inverse sine of blah, and you tell me 5 pi over 6, is that from negative pi over 2 to pi over 2? No. 5 pi over 6 is here. So you can't use 5 pi over 6. Okay? Yes. Huh? Just a second. No. The answer to one of these problems, there are only 9 possibilities for the answer to one of these problems. And the 9 possibilities are these values. In another graphic, if we wanted to show it in another way, here's the unit circle that we all know and love. Here we said this only exists from negative pi over 2 to pi over 2. Where is negative pi over 2? Here. Where is pi over 2? Here. So my values are only going to be from negative pi over 2 to pi over 2. I can have 0. I can have pi over 6, pi over 4, pi over 3, pi over 2, negative pi over 6, negative pi over 4, negative pi over 3, and so on. Let's do a couple. Look at this one. Inverse sine root 2 over 2. I'm asking you, what is the angle so that when you do sine, you get root 2 over 2? What is that angle? Or, in radian, pi over 4. Pi over 4. Okay, so now look. Where is 3 pi over 4? Here. What's sine of 3 pi over 4? Same thing. It's also root 2 over 2. But can you have said root 2 over 3 pi over 4? No, because it's not in the domain. You see that? That's what it is. Yes, it takes a while. That's why I say it over and over and over again. Okay? Yep. Now you see it. Okay. Now, it's like working backwards, but you're just restricted within those 2 quadrants. This next one, I'm going to tell you, first off, it's a trick question. Think about it. Yes?
If it was negative,
yeah.
would it be negative?
Yes, it would. Awesome. Sine of negative 2 pi. What is it? Say that louder. Okay, so this is a trick question. Remember how I said everything in here must be between negative 1 and 1? Well, 2 pi, it's a trick question. They put pi in there to trick you, and you're like, oh, that's totally cool. Because 2 pi is 6.28. That's not from negative 1 to 1. Okay? Think about that. Okay. So, I had a lovely question here. Suppose I had asked you for inverse sine of negative root 2 over 2. What would it be now? Negative pi over 4. Okay? Not 7 pi over 4. No. This is, oh yeah, so this is, yeah, no solution, not possible. Okay? One like this, right, where it's negative root 2 over 2, negative pi over 4 only. Not 7 pi over 4. I get it, 7 pi over 4 is in this quadrant. But it's not in my restricted domain. Okay? I can't say this enough because I feel like it's one of those things when we as teachers teach, it's one of those things that is overlooked. So now I go like the other extreme and I'm like, you have to get this. Okay. Now we're done with the sign. Now we're experts at the sign. Cosine. So with cosine, we have to do the same thing because cosine 2 has no hope of ever passing the horizontal line test. So we also have to restrict its domain. So we can either do this part or this part or this part. It's easiest if we go from at the closest to the origin. And why go in the negative regions when we can go in the positive region, right? So we take the part 0 to pi. So now my domain is going to go from 0 to pi. So for the inverse cosine on the unit circle, we're going to go from 0 to pi. So the angles that are included are 0, pi over 3, I'm sorry, that's pi over 6, 4, 3, pi over 2, and then 2 pi over 3, right? What else? 3 pi over 4, 5 pi over 6. So those are the 9. Again, there are only 9 possibilities. Okay?
There are like 9 possibilities.
Right, that are acceptable for inverse cosine. Okay, so take a look here. Inverse cosine of 1. For what angle is cosine equal to 1?
Oh, 0.
0.
Okay.
That's the answer. 0 is the number, right? So cosine of what equals 1? Cosine of 0 is 1, right? Cosine of pi over 6 is how much? Root 3 over 2 and so on. Okay. Now we want arc cosine of negative root 3 over 2. So you have to think about for what angle is cosine root 3 over 2. So that's either going to be the pi over 6 or the pi over 3. But we want it to be negative, so in that other column. Yeah. And cosine of 0 is 1. Because it's telling you what is the angle for which the cosine is 1. So for example, we know that cosine of 0 is 1, right? This is the angle, 0 degrees. So now it's telling you, basically, cosine of what equals 1. But instead of using a question mark, I say, what is inverse cosine of 1? Okay. What did we decide on for this?
5 pi over 6.
5 pi over 6. How about the next one? Not possible, right? Or no solution. It's out of domain. It's out of the domain because this number must only be from negative 1 to 1. So for what angle is cosine root 3 over 2? What's cosine? So what's sine of pi over 6? 1/2. What's cosine root 3 over 2? So we know it's the pi over 6. But we want it to be in a quadrant where cosine is negative. Cosine is negative in this quadrant. And so the corresponding angle to pi over 6 here is 5 pi over 6.
Why not like 2 pi over 3?
Well, because cosine of pi over 3 is 1/2. But you want the cosine to be root 3 over 2. The sine of pi over 3 is root 3 over 2.
So you want this to you want like the other to be like not go back to I don't think it would make sense. Like one of to be like 5 or 6
It has to be, it's going to be one of the special angles, right? So, okay, so pi over 4, right, is the 45, 45, 90s. What are your only possibilities for the sides? 1 over root 2, 1 over root 2. So you can't get root 3 over 2 from that triangle. So it has to be the 30, 60, 90. Okay, tangent. Again, tangent has these arms, no way of passing the horizontal line test, etc., etc. So we take one arm, and we happen to take this one. Now, watch this. What is the domain for this now, the restricted domain? Negative pi over 2 to pi over 2. Is that familiar? Which other one had negative pi over 2 to pi over 2? Sine. Except. Can this hit negative pi over 2?
No.
Can't hit pi over 2 either because there's asymptotes there. So where does that leave us? Negative pi over 2 to pi over 2, right? Now, I can have pi over 6, pi over 4, pi over 3. Can't have pi over 2. I can have 0, negative pi over 6, negative pi over 4, negative pi over 3. Can't have this one. What does that mean? There are even less possibilities for tangent. It's only one of these. Okay? So, there are several ways to organize all of this information. Let's just do these problems first. So here I have inverse tangent of 1. Yeah, tell me, Savan. You can. Oh, one thing I didn't, one thing I forgot is, what's the range here? Here? All real numbers. So the domain of the tangent is all real numbers. So when I have inverse tangent of x equal to y, only for tangent, this can be any number. This one? For what angle is tangent 1? Opposite over adjacent 1. For what angle? 45 or pi over 4. So, how about arc tangent root 3 over 3? So, I want the tangent to be root 3 over 3, which is the same as 1 over root 3. So, I want the angle such that opposite over hypotenuse is root 3 over 3. 1 over root 3. So, is that 30 or 60? That's pi over 6, 30. Okay. So there is lots of ways to organize information. Here is the chart from your book. My favorite is this one. By the way, I'm not going to graph I'm not going to have you guys graph these, so we're just going to skip these. It won't be on the test either. This is my favorite chart. This is from another book that I used to teach out of a long time ago. You know, so it basically shows you again, inverse sine of x is in quadrants 1 and 4. Inverse cosine is in quadrants 1 and 2. And then tangent is 1 and 4 again, except, you know, you don't have the top and bottom. Okay, quickly, and then I need to move on. We don't talk about the other ones. Yeah, we're not going to talk about the other ones. Okay, now, look at these. Find the exact value Here we want sine of arc sine of 1/2. So basically sine and arc sine, they like undo each other. So it's just a half. What you have to do though, and that's so cool. One thing though, one pitfall, you have to make sure that this is defined. So if I said sine of arc sine of 2, can't do that because you can't have arc sine of 2. Okay? You would just say out of domain or not possible or no solution. Oh my, look at this one. You have sine of a whole bunch of stuff. That's it, that's just half. In this next one, not yet. The first two, yeah.
Would you cancel out the sine?
No.
And sine of the one?
So this one we're going to do PEMDAS. Parentheses first. So this is sine of some stuff, right? So look at what's the stuff. Inverse tangent of 1. What is the angle for which tangent is 1? Pi over 4. Minus inverse sine of 1. What is the angle for which sine is 1? Sine is the y value, pi over 2. Yep. So now I have sine of pi over 4 minus pi over 4. That's 2. That's like subtraction, like middle school, right? Quarter up minus a half, negative a quarter. So negative pi over 4. Let's not forget the equal signs. And what's sine of negative pi over 4? Sine of pi over 4 is
Which is 3 pi over 4.
negative 1 over root 2.
Oh, it can't be 3 pi
Sine.
over 4 because sine is only 4.
Can I say negative?
I knew that.
Oh!
But for this one, okay, look. This one here is not inverse sine, so we're not bound to quadrants. This is like everywhere. Okay? Yeah. Yes. Okay. Now here, I have sine of inverse cosine. These can't go away. Right? These can't go away. So it means I have to start from the inside. Okay? So I say, what is the angle for which cosine is 4 over 5? So what I have to do is I have to draw a right triangle. So there is this mystery angle theta. The cosine of it, adjacent over hypotenuse, is 4 over 5. What's the missing side? 3. Okay, now I want sine of that angle for which cosine was 4 over 5. Where is that angle for which cosine is 4 over 5? It's this one. So sine of that angle is just 3 over 5. That's it.
That's so easy.
Right, that's so cool.
Can you do that for the other one?
You can, but you'll just get the same number.
Right.
Like for this one, you'll just get a triangle,
Right.
draw the sine, and then find the sine.
Right, so like that one?
No, because it's being subtracted. Yeah. Okay, now, because we can never leave things as simple, let's do it with a variable. Yes. So you have to do it to see what the triangle looks like. If you could. Okay. Okay, now look. I have an angle. That's it, we're done with that one. It's just 3 over 5. The answer is 3 over 5. Okay. Okay, now, I have an angle, the sine of which is x. So if that's my angle, the sine opposite over hypotenuse is x over 1. Now, I'm going to call this missing side a. So now, using the Pythagorean theorem, x squared plus a squared equals 1 squared. So a squared is 1 squared minus x squared. When I take a square root, a is the square root of 1 squared, which is 1, minus x squared. So that side is just root 1 minus x squared. Now, I know there is this desire to simplify that further somehow and say that's the same as 1 minus x, or that's, no. That is as simplified as it gets. Okay, I get it. You have the urge to like always factor and cancel something out because that's what we teach you to do in Algebra 2. We're just going to have to learn to accept that some things are just fine the way they are. Okay? Now, here. Now we need the cosine of this. Cosine of this angle theta is adjacent root 1 minus x squared over 1. So it's just root 1 minus x squared. Because here I had arc sine is x over 1, meaning opposite over hypotenuse is x over 1. Evan?
Why is it so x squared?
That's what I just said. It doesn't. Because the square root of 1 minus, it's 1 minus x squared together. You can't cancel them out like that. You can't distribute the square root. The square root doesn't, that's it. This is it. It's, we're going to learn to love it the way it is. Okay, here I have tangent of inverse cosine. So, I have an angle, the cosine of which is x, or x over 1. So, adjacent over hypotenuse is x over 1. So this, if I call it a squared plus x squared equals 1 squared. I subtract x squared. A squared is 1 minus x squared. And when I take a square root, a is the square root of 1 minus x squared. Same, there are going to be a lot of times like different variations of similar things. So tangent is the square root of 1 minus x squared over x. That's it. You can't simplify that anymore. So now, let's see here. Even though I didn't have time to solve that word problem, it's okay because it's not directly, there is not one like that in the homework. So that's fine. But do take out number 49 because that's one that I didn't, that's the graphing and I'm not going to do the graphing. However, 57, it says to graph it on your calculator and find the domain. That you could do. Just plug it into your calculator, look at the graph, and look at the domain and range. Those are algebra skills that you could apply here. Okay?